Hello, how you doing? This is me, Yafiyet Tawaldi, and I'm doing an explanation on Exam 2, Part 2, question number 1. The question asks us what the best Lewis structure for SO3 or sulfur trioxide is. SO3 has 24 valence electrons, that is 6 for the sulfur and 18 for the 3 oxygen atoms. The Lewis structure for SO3 starts out like this. Uh, with 18 electrons and the 3 oxygen atoms and 3 bonds to the sulfur. To complete the octet, we give 2 electrons to make double bond with the sulfur, giving us this structure. A formal charge analysis on this Lewis structure gives us this results, with sulfur having a +2 charge, one of the oxygens having a 0 charge, and 2 oxygens having a -1 charge. To neutralize the central atom of sulfur, we make 2 more double bonds, and the formal charge analysis on those bonds reveals that sulfur has a 0 or neutral charge, and all the oxygen atoms have a 0 or neutral charge too. This gives us the best Lewis structure for SO3, 3 double bonds, and 4 unbonded electrons on the oxygen. Question 2 asks us what the hybridization of the sulfur atom is. By the virtue of the Lewis structure of SO3, we can see that it has a trigonal biplanar electron geometry, which means that the sulfur is going to have a sp2 hybridization. Before the sulfur atom is hybridized, this is the ground state electron levels that it have, with 1s2, 2s2, 2p6, 3s2, and 3p4 electrons in their subshells. When the atom is hybridized, one shell from the s orbital and 2 shells from the p orbital hybridize or mix together to give us the sp2 hybridized sulfur atom. Question 3 asks what the electron geometry is. A trigonal planar have SO3 has a trigonal planar electron geometry. That means that the angle, the bonds, it is bonded in this form. It was the oxygen atom proportionally 120 degrees apart from each other around the sulfur atom. It is also important to notice that this the electron geometry have 3 sigma bonds and 3 pi bonds, and that is the 3 single bonds and the 3 double bonds that the structure has. As we said above, the bond angles are 120, and they are exactly 120 because there isn't any unbonded electron pair around the sulfur or near the oxygen atoms. So the bonds make a perfect 120 degree angle. Question 5 asks us whether SO3 is polar, nonpolar, or ionic compound or molecule. The polar diagram or the Lewis structure reveals that SO3 has a nonpolar, or it is a nonpolar molecule because it has a dipole moment of 0, and that is because sulfur is more electronegative than oxygen. That means the dipole arrows point away from sulfur in exactly symmetrical shape, and this symmetrical shape of the dipoles cancel each other out, giving us a 0 dipole moment. And finally, here's a diagram of what an atom of SO3 could look like. That is 3 single bonds of SO3. These are the sigma bonds, and these are the 3 pi bonds. This is one pi bond, another pi bond, and another pi bond. Since pi bonds are above and below the nucleus of the sulfur and oxygen atoms. Thank you.